Okay, this is David Zierler, director of the Caltech Heritage Project. It's Wednesday, December 15th, 2021. Once again, I'm so happy to be back with Professor Barry Simon. Barry, as always, thank you so much for joining me.
My pleasure.
Barry, today we're going to pick up not so much in the chronology, but on a thematic subject, and that is your involvement in the Torah codes issue. So just to start off, as a way of introduction, what is or what are the Torah codes?
So I actually, if you don't mind, as an introduction, I think there are a lot of interesting personalities involved. So why don't I begin by telling you a little bit about them so when their names appear, and then we can talk about what the Torah codes are.
Perfect.
So there are what I sometimes insist in my writing are not the researchers, although that's what they call themselves. They are the searchers. These are the proponents who really were searching for Torah codes, whatever they are, and I'll explain what they are. And while there are lots of people involved, the two most important ones are Eliyahu Rips and Durham Whitstone. Rips is actually originally from Russia. He's a professional mathematician, did some very distinguished work. And as you will find out, there are lots of Russian mathematicians involved in this story, and it's connected with Rips. Rips actually was almost saintly figure. You talk to Russian mathematicians and they have this sort of aura. He eventually, I think it was the Prague Spring, but I don't remember exactly what it was, but he actually protested and set fire to himself.
Wow.
And wound up in a Russian prison, went on a hunger strike. And while he was in the Russian prison, he actually proved a very important result in group theory. And eventually got out, but had this, after a lot of pressure from the West, came to Israel. And I don't know whether when he's still in Russia or just after he came to Israel, became very religious precisely because of his connection. He ran across the Torah codes, and they so convinced him that he essentially became religious.
Do you know what his point of contact with Torah was, if he had a secular upbringing, especially in the Soviet
Definitely
Union?
as far as I know, he had a totally secular upbringing, but he may have been searching a little. I don't know how he was introduced to the Torah codes.
Maybe there was
once he saw Gaon, and I think my memory is he saw codes for the Gaon and Vilna crossing each other, and he suddenly decided that this could only be there because there was a God in heaven.
We should explain that this is a reference to the Vilna Gaon, who's one of the great heroes
Right.
in Litvish Judaism.
Right. Okay. Durham Whitstone, I think is a Sabra, but I'm not positive, was a physics graduate student in theoretical physics and actually dropped out and somehow got involved in Torah codes, and he and Rips did lots of, quote, experiments together. That'll come up later in the story. A third one of these searches that I should mention is someone named Harold Ganz. Harold Ganz is an American who worked as a code breaker for the National Security Agency. As far as I know, he didn't have a huge amount of mathematical training. He had a master's degree, never did any formal research in mathematics, but he studied codes and as I'll explain, in my opinion, the codes he was looking for as a code breaker had nothing to do with Torah codes. It's totally different technology, as I'll explain when we get there. But the people who were pushing codes made a great deal of the fact that he was a code breaker. And what he claims is he actually was very skeptical and came to debug them. And he heard people talking and he was absolutely convinced. And he's been a total, and he's retired from the NSA and is basically a lecturer for one of the religious organization pushing codes. Keep losing this file. The last one that I should mention, don't know why it's there, it is Michael Drosnan, who all the other people I mentioned think is a fake, but he was very important because he actually wrote a book. He learned about the Torah codes and claimed to find in the Torah a code that predicted the assassination of Rabin.
Yitzchak Rabin.
Now, as I like to say, it wasn't prediction, it was a post-diction, because of course he found it long after Rabin was killed. But he actually turned this into a book that was a bestseller. It made a huge splash. It was got lots of media, and my indication of how much it was in people's mind is there's a favorite. There's a New Yorker cartoon where someone is sitting at the table and says to his wife, "What's for dinner tomorrow?" And she says, "Oh, we'll have to look there." And it points to a book that has Drosnan's name on it. So it made the New Yorker. That's wow. The sign of
big time.
Of big time. Okay, then there are the skeptics who are all mostly mathematicians. Besides me, there's my Rebbe, Rabbi Yitzchak Adlerstein, although when we get into the story, you'll hear he didn't start out as a skeptic. There's Brendan Mckay. Brendan Mckay is a distinguished combinatorialist who I actually ran into later. Some of the work he did is very relevant to random matrices and things that I wound up working on. He's Australian and is based in Australia. And as a hobby, he's always liked to debug fantastic claims, particularly religious claims. He's a rather virulent atheist. And he likes to say that he was particularly struck by the Torah codes because usually it took him about 5 minutes to figure out what was going on. And this really was very hard for him to figure it out. He's a very good computer programmer that's going to be relevant to this, and a very interesting character, and sort of the most important of the skeptics. And he did some work with an Israeli mathematician named Dror Bar Natan, who actually left Israel and has been at the University of Toronto, a fairly well-known. He was at Hebrew University. He's a topologist of some sort, is my memory. And I think he had some contact with an outreach organization in his youth that was rather negative. And so he also had did not come from a positive viewpoint towards what the Torah codes people were selling. And the last person I should mention is a fellow named Alec Gindis. Gindis, again, is a Russian, came to the U.S., was some kind of software expert, made a huge amount of money, and he actually provided funds at various points to the people, to the skeptics. In fact, there was a famous place where we all got together, famous time we all got together in Jerusalem. I was there anyways, and of course Barnatan was, but I think the other people all had all their expenses paid by Gindis. And it's a very colorful and interesting figure. There are other involved mathematicians. So 4 actually signed a preface to almost a preface to a book that I'll discuss later on. They are among the most distinguished mathematicians. So it's David Kashtan, Yulia Petetsky-Shapiro, Joseph Bernstein, and Hilo Furstenberg. 3 of the 4 are Russian. Furstenberg is not. He was born in Germany, but in his youth came to the United States and was an undergraduate at Yeshiva University. 3 of the 4 are religious, so they're among the frum mathematicians. Petetsky-Shapiro is not. At one point, Kazdan and Bernstein were 2 of the 3 religious mathematicians at Harvard, on the Harvard faculty. Kazdan, during the high point of this, was the chair of the Harvard math department. Kazdan, for example, is now at Hebrew University, is a Shaw Prize winner. Incredibly, Gelfand regarded him as his best student. Bernstein was also a Gelfand student, was at Harvard for a while, is now at Hebrew University. Furstenberg got the Abel Prize 2 years ago. So these are really the top of the crop. And Petetsky-Shapiro was, again, a very well-known group representation person, has actually passed away, but is quite a bit. Most of the people I mentioned are my age, but Petetsky-Shapiro is probably 15 years older. And 2 other mathematicians that I should mention. So there's Shlomo Sternberg, who's I mentioned before, who was one of my teachers at Harvard, is the 3rd of the frum mathematicians at Harvard. And Israel Alman, I don't know if that name means anything to you. So Israel Alman is a game theorist, but his work was important enough that he got a Nobel Prize in economics. And he is actually the patron saint of much of the economics group at Caltech. So there even is a Caltech connection. They very much, so they're mathematical economists, and they very much use, you hear them talk about Alman, at least clearly their patron saint. Finally, so the Torah codes were used as a fairly effective tool in outreach. And so, as you know, but some of the people listening may not, during the past 40 years, there's been a huge outreach program in the Orthodox Jewish community who attempt to take non-religious Jews and get them involved in religion. And so there are other outreach rabbis and speakers in outreach whose names will appear, who I should mention briefly. So one is Rabbi Noach Weinberg. He's the founder of Eish Torah.
Rav Noach with the Talit Katan over and over and over on his body, the famous pictures.
Yes, so he's and I actually have somewhat, it's not so direct, but his nephew is married to one of my wife's cousins. And his Rav Noach's brother, older brother, Joseph, will also play a role. He was the Rosh Yeshiva at Ner Yisrael in Baltimore and was the official rabbinic advisor to Aish, believe it or not. 2 other people that will get mentioned. So Rav David Gottlieb is actually a lecturer for Or Sameach. He started out actually as a professional philosopher, was on the philosophy faculty at Johns Hopkins, and at some point came, I think, under the influence of the Boston Rebbe and became religious, and eventually became a lecturer at outreach. He gave up his academic career. And there's someone who's based in Los Angeles was very friendly with Rabbi Adlerstein, originally based, is now the head of what's called either Darkei Noam or Chappelle's, which is a big outreach yeshiva in Jerusalem. That's Rabbi Shaya Karlinsky. And two other people that will get mentioned. One is a fellow named Gerald Schroeder, who wrote a book called Genesis and the Big Bang. I will say something about that before I get into the codes. He actually has a PhD from MIT in planetary science or something like that. He did his thesis on the study of radon concentration in basements. There was a joint program between physics and geology. And he wound up as a postdoc at MIT for about 4 years and was always described by Aish and other people as a professor of physics at MIT. And they like to present, when it was Simon versus Schroeder, it was the Caltech versus the MIT professor. I actually contacted some of my buddies who were really professors of physics at MIT, and they looked into it. He was only a postdoc there, and left to a staff position at the Atomic Energy Commission before he went and wrote this book and stopped doing anything connected with physics. But he again was described as a professor at MIT and a member of the Atomic Energy Commission. And is a fellow who sort of, I gave up on Schroeder, but always who continued to argue with Schroeder. There's a physicist at Bar Ilan who's actually quite distinguished, named Nathan Aviezer, whose name may briefly appear. So those are the dramati personae. If I had the predilection, I could have written a book called The Codes Caper and made a lot of money.
Barry, between the outreach, the Kiruv, and the Russian connection, is Chabad Lubavitch involved in this at all?
They're not involved at all in the codes.
Okay.
Although, for example, Kazan became religious because of Chabad in Russia.
Right.
So many of the Russians who are religious got involved because of Chabad.
Okay.
And I mentioned that I brought tefillin when I visited Russia. That was essentially, since I knew I needed to couldn't buy my own tefillin, I needed to get tefillin that had Chabad. I originally contacted Kazan because I knew he was connected with Chabad. But Chabad is not related. As far as I know, they've never done anything with the codes.
Barry, you've laid out the cast of characters. Now when we get into the definitions, the meanings of Torah code, just orient me chronologically. When does this story get started?
So before I do that, let me do one other introductory thing I want to mention because it's my other thing with outreach. Many people tried to get me involved in outreach, and I just don't have the time. I think it's a wonderful thing. And, we had lots of people. We had students from Caltech occasionally. I've done other things, but I've not been seriously involved. On the other hand, Rabbi Adlerstein has always spent a lot of time connected with outreach. So but on the other hand, I was therefore asked my opinion of various things. And in particular, I was asked to take a look at Genesis and the Big Bang, which was Schroeder's first famous book, particularly in the context of someone had written a book review for Jewish Action. And to say I was aghast when I read his book would be an understatement. His basic point was if you blindly took some formula for so gravity is associated with a time dilation in very strong gravitational fields. And he had the idea that, well, what's the gravitation? So there's a formula. You put in the formula for what the gravitational field is for a large mass and a certain distance. He plugged in the total, at that time, total expected mass of the universe. You took the radius of the universe as it was listed, and you put it into Newton's law to compute a gravitational field. You use that field to compute a time dilation. And because the mass of the universe is so large, this is an enormous number. Of course, the mass isn't in one place. It's spread out, but you could still do it, and you get this huge number. And so you get a gravitational dilation, and you plug 7 days and multiply it by this, and you get the age of the universe. And he thought this proved that all of Genesis must be correct, because that's where the 7 days came from. And I can't begin to say it. First of all, it shows he doesn't understand general relativity. He doesn't understand what the formula means. He didn't understand anything. I wrote a rather strong letter to Jewish Action, which was about half a page. He wrote a rebuttal that was 3 pages, and that was that. But it comes up every once in a while in thought. If you do a Google search on Simon, Genesis, and the Big Bang, you find all sorts of things where Eliezer mentioned. But this was a run-in I had, and it became a punchline almost, because I approve. I mean, I think some of it, what Aish does is very good, although they tend to misuse science, which doesn't endear them to me, and I'm not endeared to them. But at some point, when they began to decide maybe they shouldn't use the code so much, they instead shifted to using Schroeder and Genesis and the Big Bang more, to which I would comment to people, of course, Schroeder makes the codes look good.
Barry, maybe we should contextualize.
Now I should talk about the codes.
But maybe we should contextualize how you understand the Torah codes within the longer tradition of gematria and darshaning.
Okay. Well, we should first then talk about what the codes are, and I should talk about your timing. So the run-in with Schroeder was about 92. Codes, as I'll describe it to you, were actually first seriously done by someone named Weissmandl, who was a Czech rabbi in Czechoslovakia, started actually doing this all by hand, which is sort of amazing, because you really need a computer to do much. But he got into it in the late 30s, wrote about it. Then his family was wiped out in the Holocaust. He wound up in New Jersey, did some writing, and that was the beginnings of the codes. But it became serious when I think Whitstone and Rips began these experiments, and that was probably mid-90s, and my involvement was probably from 98 to 2002 to 2003. And then I regard myself as sort of retired, although every once in a while someone asks me about them, or I go someplace and I'm dragooned into talking about them more seriously. And what the codes are, so there is, of course, a huge tradition of gematria, and other numerological things that are connected with hidden things in the Torah. And there's a huge tradition about there being hidden things in the Torah. And indeed, one of the people who writes about these hidden things I think it was the 16th century, referred to something called dilugim, which is usually translated as skips. And he explicitly says, well, it isn't really known what these things are. And as you'll see, the Torah codes involve some what are called ELS, equidistant letter sequences. And since they involve skips, they were also called dilugim, and there was a claim that this really was rediscovery of this traditional method that people didn't know about it, but there's no indication that's really correct. So what an ELS is you take the Torah text, you drop written without vowels, as of course is true in the Torah. You drop all the spaces between words, so you get this long sequence and you skip in equal spacing. So you start out at one letter, you go forward 305 letters, and then again another 305 letters, and in that way you might get a word.
Barry, you can do this. We should clarify also. You're talking about the written Torah, the Chumash.
I'm talking about I'm talking about the Torah, which means the Chumash, the 5 books of what's sometimes called the Pentateuch. So Genesis, Exodus, I'm just trying to remember the secular names. Leviticus, Numbers, and there's Deuteronomy called Deuteronomy.
Deuteronomy is
anyhow, it's those 5 books.
Right.
And
right.
In fact, it's particularly popular to use Genesis to find these ELSs, but it's all over in that original text. That has a special significance because it's by tradition given directly by God to Moshe in the desert, and the other books are in fact supposed to be written by individuals who were
Nevi'im,
who were prophets and were inspired by God, but the Torah has no intermediary. It's believed to have been written and given by God to the Jewish people.
And the art of skipping spaces, that works both in a Sefer Torah, a Torah scroll, and a Chumash, a printed book?
Well, it's the same. If it's the same text, but of course you're not supposed to count vowels. So you take the printed book; it's the same text. It doesn't matter what you do it, but you don't keep spaces.
Okay.
And so you might look at every 305th letter for some number, and you get a word. So this way you find hidden words in the Torah.
Is there a rabbinic basis for this before the modern era?
It's claimed there are 1 or 2 places. So there are various rabbinic, the rabbis have played around with the Torah in lots of ways. And there are 1 or 2 places where someone might have done this a little bit, but without a computer to do searches, it's actually the number of possibilities. So individual words are almost meaningless. You can compute, I did in some article there, you look at, say, the text of the full Torah, and you take any 6-letter word, and it will occur hundreds of thousands of times. Essentially, you expect to find any word up to 8 letters, and you probably won't find. Pick a typical 10-letter word that probably isn't there as an ELS. With some spacing, of course, you could have arbitrary spaces. So single words are not so interesting. What becomes interesting is if you have related words which are, quote, near each other. And what does near each other mean? Well, that's a complicated issue. Because, of course, these spacings can be very big. So if you have a 5-letter word near a 4-letter word, and I remind you, most Hebrew words are not so long, but one has a spacing of 300 and the other has a spacing of 600, it's certainly not going to be true that there'll just be a few letters that could be near each other. But there's a way they can be made visually to look near each other. So suppose you have one of these ELSs that has a skip length of 310. And you take the text and you start writing it down on lines that are 308 letters long. So then this word that looks of letters that are pretty far apart, actually, since will occur on lines that are essentially a diagonal, there'll be one, since the lines are 306 letters long and the skip length, I think, was 308, I said, there'll be almost a diagonal with a spacing too. It looks like it's very close to each other. And if the other one might go and cross at some other way, but they look like they're actually crossing. If you write the text this way, it's visually quite striking that they actually appear near each other.
Barry, is this process, can we understood it at all in the tradition of gematria, or this is a total innovation? And we should explain perhaps what gematria is. Gematria
has to do with numerical values of letters. So in that sense, it's got nothing to do with gematria. There's a method that is well understood called Rasha Teves. I'm not sure I can, off the top of my head, remember exactly what it is, but I believe it's forming words out of taking the first letters of a phrase in the Torah. So there are other things that have play with the letters, but not in this particular way. So there's so much writing on the Torah that there are people who've done things close to this, but my memory is there are like 2 or 3 people that have done something like this in history, but there's not really, but certainly in order to actually find these things and to do the experiments I'll mention in a second you need a computer. So there's not going to be a tradition of this.
Barry, before we get to the merits of the Torah codes, perhaps we should further contextualize if there is a rabbinic basis for supporting this kind of innovation. In other words, we say that it's a living Torah, that we have a relationship with the Torah. We should always strive to have a deeper relationship with it, and therefore we can figure out new ways of experiencing it.
Well, yes and no. So it's a living Torah. There will be some people that say if you don't have an actual tradition, you don't have a Masorah for something, it's very dangerous to start using it. That actually is Rav Kolinsky's. We'll talk about that maybe a little later.
Okay.
But but you can wind up getting very striking pictures. So if you pick the lengths carefully, you will find these amazing collections. So there's a famous one that they like to show of a number of Hanukkah-related words, candle, Maccabee, that appear near each other. Again, they're not really near each other, but if you write the text with exactly the right length, they actually look to be near each other. And you see this, and it really is quite striking. And I like to call these, because these are totally uncontrolled, because who says what words to look for? My derogatory name for this is Latka codes. Not that they had latkes, but I said, you could search for anything. You could search for latka. And sometimes some of the proponents, in fact, originally, would like to quote absolutely huge probabilities that they claim that how unlikely these combinations are. So the problem is the following. To get a huge number is easy. You take, say, two words, menorah and Maccabee, that happen to be, quote, near each other. You then compute what's the probability. So Maccabee happens to occur with a spacing of 300, the other with a spacing of 250, and you compute what's the probability of finding menorah with 300 and Maccabee with 250, and you get an incredibly low probability. The problem is that this is what's known in the statistics literature as an a posteriori probability. You compute a probability after you find it without a well-defined a priori thing of the universe of objects you're looking for. Suppose it wasn't a spacing of 300, it was a spacing of 302. Would you count it? Well, suppose, now who's to say the magic words are Maccabee and menorah? Suppose this, I would like to say they were Maccabee and Latka. That's why I call this Latka codes. The problem is you can get these amazing pictures, but the probabilities that people quote are totally meaningless.
What was the rabbinic reaction when Torah codes came out? Like, what did Rav Noach say about this?
Okay, so some of so one of the things they discovered, by the way, there are experiments. So there's actually something that at least is more serious science that there's actually an article that appeared in a scientific journal. But when it was originally just shown, it really is an incredible, you take someone who comes into a lecture, they have some small interest in Judaism, and they see these pictures and they get blown away, and they hear this quotation. And so I believe some of the outreach rabbis, including Rav Noach, this was incredibly effective. And they thought, since it was effective, it was wonderful.
It was effective because it's a way of showing unaffiliated Jews. They could wrap their heads around the idea that the Torah could not have been created by people.
Correct.
Yeah.
On the other hand, so I will tell you the story now, since you asked in this context, of Rabbi Kalinsky and how he became, the skeptics are sort of anti-codes. You say the word codes to Rabbi Kalinsky, and he almost foams at the mouth. And he tells the following story. So he's run an outreach yeshiva. So what that really means, someone gets somewhat interested in Judaism and they decide they really want to spend some time really studying it, learn a little Talmud. They go to an organization like his organization. So both Or Sameach and Chappelle's very much are places. Aish also has such an outreach, but in fact, Chappelle's and Orsameach are at, I think, a much more serious level when people are really getting seriously into it and getting really serious learning. And he still gets, many times he will get students that come in who have gotten turned on by the codes, and even people who were from birth would learn about the codes. It was in the late 90s, it was just within a certain community, it was just this amazing, wonderful thing. And he tells the story that, he was always somewhat skeptical. And one Purim, he and some of the students, they drunk a little bit, and he was a little lightheaded. And he said to one of the students, sort of, he decided to chapter him, if you know what that means. He said, well, yeah, I understand. Suppose you found a code that said you should keep Shabbos on Sunday. Now, it isn't clear what that means, but... Okay.
That's a provocation is what it is.
The student said, oh, you wouldn't find it. Yeah, but suppose you found it.
Right.
Oh, then I'd have to think we might have to keep Shabbos on Sunday. At this point, Rabbi Karlinsky realized how terrible this was.
Yeah.
Because we have no real tradition, but it could be terribly misused.
Would we put this in the same category as the Karaites who rejected Torah Shel Ba'Peh and who ate in darkness on Shabbos?
Sure. Some people could say that. That's a little bit, but it's just very dangerous to use something which you don't have a tradition for, and which you can essentially find anything and start throwing numbers around. And, Rabbi Gottlieb is a similar situation. He really is. So there are many Rebbeim who are very anti-codes because they think it's dangerous. And by the way, there are also Christian codes. So there are ELSs. There's a wonderful ELS. I can't remember exactly what it is, but I think it has Jesus and Messiah crossing each other somewhere in Isaiah.
This should be the exit ramp for frum Jews when they think about the Torah codes right there.
And the people from Aish who continued to push codes would say, yeah, those are false. Those don't have a scientific basis. And they don't really have a good reason for why those codes are worse than some of the Latka codes they use. Of course, there are these other things which are rather different. But I gave a lecture one time at Yeshiva University of Los Angeles on the Bible codes, and afterwards someone came dragging a friend. He said, you really have to speak to my friend because he heard about the Torah codes. He decided, gee, this stuff really must be real, and decided he should convert. He should become a serious Shabbos observing Jew. And 2 weeks ago, he was introduced to these Christian codes, and he wants to convert. What can you tell him? And I said, it's all nonsense. But the point is, it's very dangerous. And this exactly shows why it's so dangerous.
Barry, let's engage on a technical level. I wonder if you can explain why you need computers and what the supposed math is that legitimizes Torah codes.
Okay. So you first of all need to find compute because there are so many. Remember, I said some word occurs hundreds of thousands of times. So first of all, you have to decide one of the things that people became popular at some point is not, there are so many ELSs, you look for what are called minimal ELS. So that's one with the smallest spacing. Now, of course, in order to find one with the smallest spacing, you need to do this search of this huge text for all possible times the word, say, Hanukkah occurs, to find the one with the smallest spacing. You need a computer for that. And indeed, in the famous Hanukkah code that people like to show, that made this big, where they made the big deal about these are minimal ELSs, the word Hanukkah isn't used. It's Ha-Hanukkah, even though we rarely use Ha-Hanukkah. Why? Because in this particular picture, the Hanukkah is not minimal. There are other places, but if you add the hay in front, it becomes minimal. Now, this sort of illustrates the thing that was my big push on against the Lotka codes, and is the issue of what I call wiggle room. The fact that you can manipulate and means that these things are essentially not significant, that you really can't compute probabilities. Okay, so now we can talk about mathematics. So Whitstone, who had a serious, was a graduate student in physics, had a serious academic background, began to ask himself, how might we prove that these things really weren't some artifact of just luck? And he had the idea that, well, what we need to do is sort of look for some systematic way of combinations of words that are close to one another, and some way of figuring out how unlikely that is. And so they invented some absolutely cockamamie method of measuring how close two ELSs were to each other. Wasn't based on visual, but some mathematical formula, but at least made things well defined. And then he didn't have a good idea. He had some early version. I'm not sure of the exact history of how Diaconus, one of the mathematicians I forgot to mention in the picture is Percy Diaconus. So I don't know if that name means anything to you. Diaconus is a statistician, probably has a joint, in fact, I know he's a joint appointment in mathematics at Stanford. Has a very strange history, got into mathematics late, is actually a professionally ranked magician, and one of the sweetest, most interesting guys, and really clever. And while he's officially a statistician and a combinatorialist, he really is noteworthy for applying these things to other parts of mathematics. So he has some amazing papers on understanding random sequences of matrices that rely. Anyhow, he's a really impressive, fantastic guy. And he got involved. I suspect I know why. I'll come to that in a moment. But he was consulted, and being a very clever guy, he came up with a way of deciding how likely or unlikely some combination is. So in the actual experiment, we had a list of names and a list of dates where the names and dates were correlated to each other. So we had, say, 100 names and 100 dates. There's the correct names and correct dates. And we use our method of finding the minimal ELSs or some other way that these pairs occur in the Torah and how close the names are to the dates, to the correct dates. And he said, if you want to see how unlikely this is, why don't you do why don't you just do a different permutation? So you have in fact, I believe it was 30 names and 30 dates. You have a huge number, 30 factorial, of ways of permuting so that the wrong dates or only some of the right dates are next to the names. You have the list of names that you fix. You have the dates which have a collect listing, but there are lots of ways of permuting the dates so that most of them are associated with the wrongs. And you do the experiment again to see how long, in this particular different pairing, how close the names are to the corresponding dates. And so suppose you have, 30 million, and you don't do all because it's too much to do all of them. You randomly pick, you use some random way of picking 1,000 randomized pairings, and you see what rank you have among these 1,000 possibilities you did. And if it's a low rank, that says, oh, gee, the fact that it occurs that way in the actual text with the correct pairing is some indication of real significance. And so the famous paper that Whitstone and Rips wrote, there's a third author, but the third author, I was told, was just to do the computer programming for them. So he's typically forgotten. What they did is they took a list of medium famous rabbis and medium famous dates, which were, they picked the rabbis by, they took again, they wanted to show that they were not choosing it. It was an a priori list. They took some encyclopedia and they took all rabbis whose articles were between 1.5 and 3 pages long in this encyclopedia, which means someone like the Rambam didn't appear. And they got 30 rabbis, and they took the date of their birth, and they took the names of the rabbis and the names and the dates of birth, and they did this mix that we talked about. And they found out of 1 million permutations. I don't remember the exact numbers, but it occurred, eighth in this list of 1,000, which is fantastic. Now, one of the figures that's involved here. So one of the things, by the way, that happened during the preliminary, before the actual paper appeared, Whitstone wrote a book with some preliminary versions of this. And as you may know, there's a tradition of getting hashkomis, the approvals from big rabbis. You write a sefer, you write a book about your interpretations of some volume of Talmud or something else, and you get some big rabbi to write a letter that says, I think this guy is wonderful. And, the standard is, my father knew his father, and these are letters that people write as favors, and they're not, they give it some luster, but the writers don't take it that seriously. And Whitstone decided to do the same thing from some mathematicians for his book. And there was a preface that I believe was probably written by Kajdan, who was struck by this. So a number of religious mathematicians, it was interesting. They thought this was an intriguing thing that was being done. And he got 4 famous mathematicians to sign this letter that didn't say, we approve this, it just said, we think this is interesting research and it's probably worth following up. And so he got Kazdan and Furstenberg, who later, by the way, said if he realized how much flexibility there, he would never, and he regrets having signed the and will come up later in the picture. And he also, Bernstein and Petetsky Shapiro also signed this, although when I consulted them, essentially both said, don't ask me, I signed it because Kazdan told me to sign it. It was for Rips, and everybody knows what an angel, what a sainted person Rips was. How could I not sign it? But my exposure to this came, so Rabbi Adlerstein also was struck with this. He was originally a proponent. He and I knew each other. He was not quite my Rebbe when I was originally exposed, but he suggested to one of the local Aish rabbis that there was this well-known mathematician in Los Angeles. They should perhaps get me involved. I might become a wonderful lecturer on the subject. And so I was invited to attend one of these presentations that they were giving on the codes. It was given by someone I actually knew, and he actually had a prepared script. He didn't really understand much of the mathematics involved. And I sat there, and it was not quite as bad as my reaction to Schroeder, but I was pretty much aghast, because it was clear to me that much of the beginning, before they got to the actual experiment, which I didn't understand, but the original Lotka codes were clearly misusing a priori probabilities. It was clearly just Narishkeit. And the other one, well, I needed to study. And these, I was told that it had appeared in a journal. And of course, if it appears in a journal, it must be correct, what we were told. And of course, I know enough about journals, as I said in one of my articles. I've been an editor of a journal for many years. At that point, it was 15 years that it was 35 before I stepped down. It has incredibly high standards, and I wouldn't eat in a restaurant whose kashrut only had a standard as high as the journal. And scientific journals, referees are busy. They do the best they can, but I know referees whose attitude is, and it's almost my attitude, it's not your job to decide whether it's correct. You assume the author knows what they're doing. It's to figure out if it's plausible, so there isn't anything obviously wrong. And it's important enough to appear in this great journal. But it was presented in the lecture, appears in a scientific journal, that's proof, must be correct. And then there are these famous mathematicians whose names I knew at the time. I don't think I knew any of them. I probably met Kazdan, but not the others. And I was just totally aghast.
Barry, let me ask you, before you approach the Torah codes from a technical level, as a frum Jew on an emotional level, did you want it to be legitimate? Were you disappointed when it turned out to be nonsense?
So on a personal level, I don't like black magic. There are good reasons to have faith. Gematrias, and I understand there are some that are divine, but gematrias are a pleasant, it's a nice seasoning in your cholent. But it's not what you eat. It's not the reason to, right? So, no, I would not. But again, from the very beginning, since they started out by presenting these Latka codes as being somehow amazing, and I knew that they weren't amazing, I was never at a point where I could be disappointed or not disappointed. It was obvious nonsense from the start for me. In fact, if they'd started with the more scientific things, I might have taken it more seriously, but they began. In fact, one at my wife's cousin's house, we met. There was an Aish rabbi he walked in. I was introduced to him, and he essentially looked at me. "You don't have horns," was what he said to me. Because Aish, at this point, Aish and I were.
Yeah.
But we had a very interesting discussion, and he had what he said. We talk about the high impact, low science codes. That's what I call logic codes, and low impact, high science codes. So this experiment, which puts people to sleep, they don't say much about it because you get into the technicalities. It's interesting to someone like me, but not to it. But it's supposed to be real science because it appeared in this journal after all.
Barry, I wonder if there's a duality to your reaction as well. Obviously, as a mathematical physicist, you're offended when you see research that's nonsense. But as a Frum Jew, are you also concerned that this is a bad image problem for Frumkeit?
So I remember in the middle of this, Rabbi Adlerstein went to his Rebbe. So my Rebbe has his own Rebbe. This is the Rosh Yeshiva of the Chafetz Chaim Yeshiva, which is where he went, who's now passed away.
This is in Queens.
In Queens, and he was at the time probably in his late 70s. And in fact, I have a son that was a student there also. He was a student. This guy, in fact, it's named because he was a student of the Chafetz Chaim. So he's a remarkable guy in many ways.
By the way, Barry, I know that you became later after you had the chance to be a yeshiva bacher, but just in terms of your own rabbi, do you consider yourself a Chafetz Chaim guy?
No, I'm not. I don't really know.
You don't have a yeshiva affiliation personally?
Not at all. And in fact, my other two sons both went to Torah Moshe, which is in Jerusalem. And the rabbi there, in fact, has a PhD in mathematics. But this is an aside.
All right, so going back to your Rebbe goes to his Rebbe. What does he say?
Right. And he said, and he asked the question, can you lie to someone to get them to keep Shabbos?
Classic rabbinic question.
And he told me he was expecting he was going to get an answer that the seal of HaKadosh Baruch Hu is emes, is truth.
HaKadosh Baruch Hu is God.
An answer that you can't.
Not to mention the concern of blowback that if a person feels like they got into this.
No, that's the answer he got. So he didn't get this answer. He instead got the answer. No, absolutely not.
Yeah.
Because what if he finds out you lied?
Right. You
So,
gain 4 Shabbosim to lose a lifetime of Shabbos observant afterwards.
Correct. So that's the answer he got. And so, on the other hand, I do understand there's a problem outreach people have of you. The way it's described, the best way of describing it is you got to bring people in.
Yeah.
Someone once said to me, you shouldn't care about this. You bring them in, and so you lie to them a little to bring them in. Now, you can't do that. To me, that's not right. But you bring them in, and the Torah codes were incredibly effective of taking someone with a little interest and piquing, if they had no scientific. It's very bad for people with serious scientific background because they see through it. But people who have a little bit, who are sort of wowed by these, they hear. I thought I turned that off twice in 2 different ways. It's crazy. Anyhow.
Barry, to go back to, I think, our very first conversation, where you emphasized that you really separate your Torah worlds from your science and math worlds because they don't speak to each other, right? So is the Torah codes, which so obviously wants to connect both worlds, does that only emphasize the point that you made, that there isn't any need to do it? One does not need the other to be self-sustainingly legitimate.
Well, it's not only that, it's that an attempt to make them connected is likely to have some faulty basis. It's not that it has to. There are, Avi has a book that it's not my kind of book, but it's actually pretty good. You can attempt, you can do some writing that attempts to link some aspects of science and Torah, but much of it, I once said, books on Torah and science that I've seen, and there may be a few exceptions, but probably not, are either bad Torah or bad science, and usually they're both. I think that's certainly true of Genesis and the Big Bang, for example, Schrodinger's book. And I think it's true of codes.
I mean, to just be as simple as possible in your relationship to God, you need faith, and that simply does not work in science. It's not relevant in science.
Well,
you have evidence in science. You have observation.
Yes and no. So there's a famous medrash that I love to quote. In fact, it's sort of sad because there's a rabbi high up in the OU who was in charge of their conference section who became friendly with Bill Clinton. And he had people write weekly drushes for Clinton. Clinton liked to read it. And so I actually wrote a drusha which essentially repeated this famous medrash about Avraham. When he was young, he went out and saw how magnificent the moon was and decided he should worship the moon. And then the moon set and the sun came out and it was clearly, but eventually he decided there had to be something that had caused the sun and the moon, and that's what he should worship. And there is a sense, you look at nature, and as the theoretical physicist said to me in the lecture I told you about, it's hard to imagine that all occurring at random. So there is something about science and nature that really does mean they're not quite totally separate. But the explanations are going to be different. By the way, I submitted this drusha to go to Clinton, and the Monica Lewinsky scandal broke the day before he would have gotten the drusha, so I never got any feedback.
He was a little distracted.
Correct.
Barry, when did the Torah codes controversy kind of simmer down?
So they sort of stopped. So one of the things Rabbi Edelstein, I got incredibly involved. Rabbi Edelstein and I actually made a pilgrimage to the yeshiva in Baltimore, whose name I'm blanking on, that Joseph J.B. Weinberg was the rabbi of, because we essentially wanted to, one of the things that Rabbi Edelstein convinced me is that these things were so dangerous and so bad, we had to get some big rabbi to essentially take a position that you, and the obvious choice was in fact, and we went to see him. And I remember probably that time we were paid I did allow my airfare to be paid by Gindis. And on the way there, he said to me, Rabbi Weinberg, I regard as one of my rebbes. If he says I have to stop, I'll have to stop, but you don't have to stop. I don't want you to stop. And it was amazing. He clearly had thought about this, and he essentially said, no, there's no way this thing can't. He had various reasons why he was sure they were wrong. And he essentially said, and there was this amazing thing, there was one point when he was so negative about it that Rabbi Adlerstein had to play devil's advocate. And he said, you can say in my name, you can't use this, and I'm going to discuss it with my brother. And then at some point he got pushback from his brother, and he was convinced that the only proper thing is that I forget who was going to do it with me, and there were going to be Harold Ganz and someone else were going to have essentially not a Beis Din because it was only them, but we were going to meet with him, and he should hear the other side before he took a definite position. And shortly after this happened, he was diagnosed with cancer and we never met, and he was dead 6 months later. We also, before this, we met with Rav Shmuel Kamenetsky.
We should say that Rav Kamenetsky is considered perhaps the Gadol Hador in the United States.
At the current time. And if his father before him was one of the Gadol Hadors. Gadol Hador means greatest rabbi. Yes.
Yeah.
And he was just aghast. But he said, look, this is terrible, but it's Rabbi Weinberg. It's Rabbi J.B. Weinberg. You have to convince him.
Yeah.
So he was convinced, and you have to. By the way, Rabbi Karlinsky was definitely a Talmud and was, in some sense, Rabbi Kamenetsky was the rabbinic advisor to Rabbi Karlinsky. Rabbi Karlinsky had been after him, but his position was he didn't want to get involved. We also met with Rav Sternbuch, who's a big Rav in Jerusalem. Very known as an intellectual, and the conversation he began before we could say anything. He said, Torah codes are obvious Narishkeit to anyone of the slightest mental acuity. But if they're effective to convince those who are of less than the greatest mental acuity, then who am I to say they shouldn't use it? So it was a very, basically, you have to decide what battles you want to fight. And essentially, the rabbis we went to see decided it wasn't battles they wanted to fight. And I can understand why you don't want to use your intellectual and so I wound up for a period of a few years. I gave, I don't know, probably a dozen in various places, anti-codes talks in various places, in semi-religious settings, to show you how charming Rips can be. Rips actually came to one of the ones I gave in Jerusalem. And afterwards, he came up to me with this really charming smile. He said, that's the best talk I've ever heard. Pause. Except for the content.
That's great.
Because I really did put on a good show. I mean, I had lots, because, one of the things that Brendan Mckay did is Drosnan in an interview had said, when my critics find predictions of the assassination of Prime Minister in Moby Dick, I'll eat my words.
There
and
you
so
go.
Mckay found lots of amazing. So there's particularly a famous. So they have their pictures. I had this amazing picture with Princess Diana, and it's an amazing. You see some of these things Mckay produces, and you understand why the Lotka codes are total monarchite.
Barry, to put a bow on this particular aspect of our conversation, if not the Torah codes itself, if we could zoom out again on what the Torah codes was trying to do in demonstrating that, as I said earlier, Torah clearly could not have been generated by humans because of this amazing capacity. Are there other aspects of the Torah that do have that characterization? Like, do you see the Big Bang in Bereshis, or any number of other examples?
Well, you do see them, but again, so there's no question that it's very, but there are two problems that you have to bear in mind with an example like the Big Bang in Bereshis. So one is the so-called problem of the God of the gaps. I don't remember the exact, but the part of the issue is, if you claim that something like this proves, right, it can't be explained any other way, and then science comes along and finds some other way of explaining something, where do you stand?
Yeah.
So that's one of the problems. And the other problem, so I'm not sure I quite subscribe to this, but I certainly remember in discussing codes, there are some people who feel you can't have anything that proves the Torah is, without a doubt, the Torah is divine, because that would take away people's free will. It's an argument I've heard. It's not one that appeals to me. But I understand the need to bring people in the door, because we have a lot to offer. If you just, as someone said to me, we just have to get them in the door. Then they see people singing Zmiros on Shabbos.
Yeah, right.
And you've got them in. And I understand that, right? One of the Aish rabbis was going around after my article in Jewish Action appeared, saying, because of Barry Simon, the intermarriage rate is going to go up. Talking about Lashon Hara.
Yeah, seriously. It sounds like
I understand why he thought that.
It sounds like for you, though, what it's about in terms of kiruv, in terms of bringing unaffiliated Jews who do not have a background in Torah, the way to do that is through conveying values, not through trying to show evidence.
That's correct.
Yeah.
That's correct.
Right.
What we have to offer are a combination of values and a system that fits together.
Yeah. And the emes there is that we're here and we still have these values from thousands of years ago.
Well, the emes is also, if you try living it for a while, you see what its value is.
Yeah. Barry, we talked about the Torah code wars. Now let's go on to a different set of wars, the math wars. But as prelude to that, first we need to talk about the Stevenson Committee at Caltech from 94 to 96. So, first of all, which Stevenson? There's a few Stevensons at Caltech.
Dave Stevenson.
This is Dave Stevenson.
In geology.
Right.
So
what is the Stevenson Committee?
Okay. So Caltech still has, but has long had a quote core curriculum. So Caltech has relatively few graduation requirements. The idea is, at least in most departments, it depends on the department, but the mathematics was the most extreme. But the idea is, Caltech has all these wonderful courses. You want students to learn some basic material that makes them a professional, but you want to also give them lots of opportunity to. So there are relatively few requirements, but one set of requirements are institute-wide. They are core courses that all students must take. Many schools have this. And until 1995, I'm not sure when it was put in place, but I think it was in the 30s or early 40s, all Caltech students had to take 2 years of mathematics. That's 6 quarters. Of course, Caltech is on quarters. 2 years of physics. And essentially 4 years of humanities and social sciences. The math and physics were specific courses. The humanities and social sciences were from a menu. And I can't remember what else there was. I think you had to take at least one course in either biology or geology and earth sciences. I can't exactly remember. But there began to be a lot of pressure about this and discussion about whether this core needed to be updated. One of the reasons was that we became aware of the fact that many of our graduates, still true unfortunately, don't know how to write coherently, don't learn how to speak. That's not part of what we did in class. And, as I'm fond of saying, it's not so much that physics is the science of the 20th century and biology the science of the 21st century. It's that physics is the science of the century that ended in 1960, and biology is the science of the century that began in 1960. And here in 1998, we expected our students to take 2 years of physics and no biology. And so there was a suggestion that maybe, now of course, this being Caltech, of course, Caltech it was always run until David Baltimore, the Caltech president, was always a physicist. And always it was run by the physicists. And of course, students, of course, have to learn physics, but perhaps they should also learn a little biology. And so there was a committee that set up how to redesign things to add some biology, some communication classes. But the other part of the picture was that we didn't want to just add on courses. We didn't want the number of courses in the core curriculum to get larger. So if we were going to add something, we had to subtract something. And so Stevenson was made the chair of a committee that had, I believe it was at least one representative from each division, but clearly we needed both someone from physics and someone from mathematics. I forget who was the physics representative, but I was the representative for mathematics. And we would systematically look at it. And there was a preliminary report. I remember the faculty board, essentially, there were too many things that they weren't happy about. And so we actually wound up taking 2 years before we came up with the final proposal. And one of the things we did, for example, one of the things we decided we do is we polled each of the divisions about what they thought should be in these required math and physics classes. And should it be so much? And one of my favorite Caltech stories is that of all the divisions, only one came back and told us they thought we should include calculus on Banach spaces in our math class. And that was the division of humanities and social sciences.
Wow.
Because, of course, half of the division are economists. They've been influenced by Alman, as I mentioned.
Yeah.
And, I still remember going to meetings of some committee that happened to meet over there. And I walk into the room, and written on the board is let X be a Polish space. That's a mathematical notion. They're very mathematical, the economists. We, of course, decided not to do calculus on Banach spaces, although I should tell you, at Harvard, there is a calculus sequence, the one that I took, for example, that does calculus on Banach spaces. And there really should be such an honors class at Caltech. The problem is it wouldn't be big enough. It's not clear how you figure out who goes in it, because all our students think they know everything. And so we a number of times we discussed whether that might be possible, and we never really did that. We sort of do that a little bit in passing, maybe in a more advanced class. But the Stevenson Committee in physics, the solution it was decided we needed to do is go from 6 quarters to 5 quarters in math and physics. That added a quarter in biology and a quarter for the communications, the science communications. And that's basically but then we had to figure out how we went from 6 to 5. And in physics, they just lopped off. They lopped off waves. I don't remember it, but they had 5 quarters. They just said, well, this one's not so important. And they just lopped off. In math, we actually had a different way of thinking about things. One of the changes was it used to be that all our students come in having taken advanced placement calculus, but we know when we test them that they don't understand calculus at the level we really want them to. And so there used to be essentially 2 quarters of basic calculus, with the students complained that we know, most of us know this, and so there was a decision that, well, we could really, the solution was, we'll take the students at their word. So we would cut down these 2 quarters into 1 quarter. And there was a further push. The biologists, so one of the things that happens that the mathematicians are pressured about, the physicists would like us to do multivariable calculus on day 1, because certainly by the time we get to the 2nd semester, because they need that for electricity and magnetism. But there's no way we can possibly do that, because they first of all have to really understand 1 variable calculus, and you need to do linear algebra before you can do multivariable calculus. So we told the physicists a long time ago, no, there's no way we can do that. But the biologists say, since the new scheme, one of the things was that people would be pushed to take this required term of biology in the first year. They wanted to be sure that sometime in the first 2 quarters, they learned some basic probability. And so we came up with a really terrible recommendation. We split probability and statistics. So the first quarter of the math sequence that the Stevenson Committee recommended was 1 quarter which did some of the basic calculus, leaving the rest of the basic calculus, the series and other things, to the 2nd quarter. So 5 weeks of that, and then 5 weeks of probability, because it used to be 5 weeks probability. And then in the 2nd year, we had a class that did some of the advanced linear. We also split linear algebra so that some of it was in the 2nd quarter. Some of it was combined with statistics in the 4th quarter. And the students eventually, so I taught the first quarter for 5 years, as I'll tell you in a second, but the students eventually rebelled. And it may have been in the last of those 5 quarters I taught it for, we'd already changed. I don't remember now. It may have been just afterwards. But eventually, we just, we pushed the biologists. It turned out they really didn't use much probability. And so we probability and statistics are now back in the second year. It's a much more sensible curriculum. But in the original thing, I decided, I was pushed. Why don't you teach this? Now, I've always taught just advanced classes. I really have not taught any, but I was convinced to teach the first term of required math, the first experiment of these 5 weeks. And I didn't like the book that was being used, which was Apostles' Calculus. I didn't like much. I wrote my own notes for that. And we used a probability book that wasn't too bad. And so I taught 5 weeks and you should realize that at Princeton, I probably typically taught classes with 25 or 30 students. At Caltech, the basic advanced classes I teach will have between 10 and 20. The topics classes will have 5. Math 1A is the largest or second largest class at Caltech. The first term of the applied math class, which is not required, but almost every student takes it, and many graduate students take it, may be slightly larger. That's taught in the applied math department, not mathematics. But this is a class that has roughly 200 students, much larger than that. And it was very interesting. We had these large lectures, and then there were sections, so I had to manage 10 TAs. It was very different. We had to worry about grade. It was a very different experience. It was interesting. And I was doing this different curriculum, and the real point was to teach them what a proof was. And you may have seen this famous picture of me in the Epsilon and Delta gloves. I don't know if I told you where that came from.
No, you didn't. I want to know.
One year, I had one year I had a particularly lively class. It was really quite remarkable. And one of the standard lines that I gave every year was, "We don't really understand calculus." Sorry, that's a different one. That Epsilon and Delta are calculus students' finest weapons. And so probably my third year teaching the course, I walk into my last lecture and the Epsilon and Delta gloves are sitting there on the desk in the front of their gift from my students. And I get back to my office and they'd stolen a traffic sign, a Pasadena traffic sign. It's typical Caltech that said that, and posted it on my door. It said, "No passing zone." So it was a particularly lively class. I had lots of interesting. I would also tell students, if you don't understand epsilon delta proof, you don't understand calculus. I remember after one of those lectures walking back, and I happened to be behind 2 students who didn't know I was there, and one of them saying to the other, "I've took calculus for 3 years in high school. How can he say I don't understand calculus?" And they don't.
Barry, some questions about broader trends at Caltech that might give some context to both the Stevenson Committee and the redesign of the core curriculum and how that affected the kinds of classes you taught afterward. So a few things are going on in the mid-1990s. One is that the shift in undergraduate interest from physics to computer science is underway. And another is that as we get closer and closer to the present, fewer and fewer Caltech undergraduates go on to graduate school and instead want to pursue careers in industry. So I wonder how either or both of those trends might have been a factor in the Stevenson Committee and the core curriculum redesign.
They were not in that committee. trends you're talking about a little later, there was a later further core curriculum design in about 2010 or 12 that in fact cut down the required courses to only 3/4 math and physics. And there was lots of discussion. I can't remember what the resolution was about what was to replace it, but it was there. I think there are fewer courses, but there also was lots of discussion about something that, for example, there may now be a formal computing course that students have to take. I just don't remember. I didn't, I was getting close to retirement and I knew I was not going to teach undergraduates again, so I didn't pay that much attention. But there's been, so the effects, the trends you're talking about were, I think, shown in the second level of redesign, which was in many ways much more radical, but less controversial. It was amazing. Every little change we wanted to make, I don't know what the fraction is, but probably 20 to 30% of the Caltech faculty were Caltech undergraduates. And any little change we wanted to make in the original core, but you can't do that. It was one of the most important courses I took when I was here.
So the newly designed Math 1A in the late 1990s, right? What is the connection? How do we get from there to your involvement in the so-called math wars?
So one of the things I discovered in this class, I assumed I didn't pay much attention to high school mathematics, but now I had to care what my students came in knowing. And I was supposed to be teaching them proofs. I assumed everyone had, when I was a high school student, I had a year of, quote, Euclidean geometry, which did these terrible 2-column proofs that are the worst possible way of learning about proof, except for every other, in the quote, to paraphrase Winston Churchill. They're not a very good way of really understanding, but they've exposed people. You've actually spent a year thinking about what a proof is. And part of the reform of the math high school curriculum in starting about 1985 to 1990 was, which some schools absorbed and some didn't, was to introduce all sorts of things. But one of the things I did is I did a survey of my students to find out how much proof they had in their high school geometry class. And it was roughly equal thirds. 1/3 had the traditional class that I had that probably high school students had for 100 years. 1/3 had a month of proof, and 1/3 had no proof at all. And I was and remain aghast by this. So after mulling this over for a while, one day I started probably the evening before, but I'm a pretty good writer, so I wrote this, and I had some idea of how long editorials were supposed to be. And I wrote an editorial, which you can find on my webpage, called A Plea in Defense of Euclidean Geometry. And, just for the heck of it, I sent it off to the LA Times. But of course, I identified myself as the chair, because at the time, by then, I was the chair of the math department at Caltech. I was actually not the chair because we don't have chairs. I was EO, but I misdescribed myself as the chair of the math department. And literally 30 minutes later, I got back an email accepting my editorial for the LA Times with a standard contract, which I signed, which I didn't read or understand, without my realizing it, I gave them syndication rights. And so this editorial, for the next 3 years, I'd every once in a while get a flurry of letters that people wrote me because a syndicate of this a reprinting of this in another newspaper had suddenly occurred. And of course, the LA Times got paid for this every time that they reused my thing. I didn't get paid for the original one, let alone for its reprinting. I'm sure they made a lot of money off me, but that's life. And I also got an email several emails from people who were in what I would call the math wars. One I like to tease was a letter that said, "Oh, I'm so glad to read your editorial. You can be cannon fodder." So basically, what happened is I was not the only person who was concerned about the change in the curriculum, which didn't only involve Euclidean geometry. It's a whole trend that has continued and has reoccurred of tracking is immoral. It's complicated. Whether tracking is good or bad is complicated. One of the arguments against tracking, so tracking, of course, means putting the better students in a different class. One of the arguments against tracking is, of course, by separating the better students can be a goad, can help the weaker students. Of course, they can also discourage the weaker students. I believe that tracking is a terrible thing if you have great high school teachers. But unfortunately, in part because we don't pay teachers very well, we don't give them very good working conditions. On the whole, we are lucky. We do sometimes have very good high school teachers, but a lot of them aren't so good. And I think not tracking is much worse. In addition, there was a huge tendency to what I'd call dumb down. So you ought to face the fact that there's a significant fraction of students that have trouble understanding even the watered down curriculum, but certainly the curriculum I went to, there's some students that had a lot of problems with. And dealing with that is a hard issue, and I'm not quite sure how to do that. But of course, one way of doing it is, if some of the students don't understand some of the material, we just won't try to teach that material, and then we don't. And the caricature of the new curriculum that was being put into place is we don't want to challenge anyone, because then some of the students won't be able to do it if we challenge them, and they'll feel bad, and we don't want that, and so we won't ask anything of them.
Barry, because Caltech undergraduates are really the creme de la creme, right?
Yes.
What aspects of the K through 12 math teaching are relevant for Caltech education, and what are your just overall concerns about math education in the country? So
I was more concerned about my students in the sense that they should be able, the students I'm saying, but I'm concerned about the training, not just Caltech students, but students who are going into STEM. There are students who aren't going into STEM, and they're a problem, but I'm not particularly. But you want to be able to be, we are competing with China, let's say. You want to be sure that that my biggest concern is for students that wind up going into STEM. I care about people, but this was the editorial was more a cry from the heart than this is something I care about so much I'm going to spend lots of time on. But having stuck my head up, I wound up getting sucked in because there was a very active group of people who were fighting back. There was it wasn't my name, what people were calling the math wars. There were certain people, most of them associated with education schools, that were claiming studies show, and blah, 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 blah. I'm not sure there were very good studies, but that essentially tracking was bad, you're trying to teach too much. And then there was the reaction that said, no, you can't, you've got to be sure, you want to try to help all students, but your solution for helping all students can't be to hold back the good students. You have to try to deal with everyone, and the traditional way is not so bad. We may need to rephrase things to be clearer. So there were some professional mathematicians. There were three in particular. There's a topologist at Stanford named Jim Milgram, differential geometer at Berkeley named C.S. Wu, and an analyst at Wisconsin named Dick Askey, who actually I later had much to do with because he's a big guru in the theory of orthogonal polynomials. The so-called algebraic side, not the side I worked on, but we had a lot to do with each other. And he remained very active in his science. Wu essentially was full-time in math education. Milgram was close to full-time. And I knew Milgram somewhat, and he sucked me into, I met some of these people. I encouraged them. I was not planning to do much myself because I had too many other things on my plate. I was a department chair. I was doing my research. I had graduate students. And I get a call from Milgram one day that there's a new framework for teaching mathematics. Oh, and one of the other things, by the way, that the bad guys in the math war were also pushing that made me aghast, but it has definitely become fashionable, that the traditional curriculum is Eurocentric.
Like white male Eurocentric.
Well, in those days, it's now become white male. In those days, the phrase white male was not so whatever. More recently, it's evolved from Eurocentric to white male mathematics.
Right.
But it's the same thing. It's recurred, and this time it looks like the bad guys are really going to win. You may know there's a new framework that's the draft framework that is it's got all the bad stuff. It's total victory for the time being because these things can be looked at. There's a new framework every 10 years. But there was a new framework that had been proposed that had various changes that were looking good. And the LAUSD, that's the Los Angeles Unified School District, which is the second largest in the country, even in those days, I think had a budget of $7 billion. It's a big operation. They had a textbook commission to try to recommend textbooks to meet the new framework. And there had been one of the appointees on this committee was the representative. It turns out Los Angeles County has a board of education. No, it doesn't have a board of education. It has superintendent of education, even though it runs no schools. But it's someone, and the superintendent who was supposedly on the side of the good guys in the math wars, from my point of view, had a representative, and his choice had been too nasty. And I know the guy who it was. I didn't know at the time. He can be rather acerbic. And he was essentially kicked off this committee, and they wanted me to replace it, and it wouldn't be very time consuming, and would I please agree to do it? And like a jerk, I said yes. And I wound up for 6 months being and it wasn't that bad in the sense that it probably only took a day a week out of my career. But it was very educational for me. I learned an enormous amount. It was so unlike any Caltech committee I'd ever been on. You know, basically, we often had meetings that ran from 9 a.m. with a lunch break till 5 p.m. and got nothing done. In part because at Caltech, it's well understood all the work is really done by the chair of the committee, but other people get input, but the chair is there to be a policeman and make sure that. And the chair was totally different. He was a political beast. He was some bureaucrat from it was just. But the other problem was that I had a very forceful personality, and for the first 2 months, it looked like I was leading people in the right direction. There was again a member of the State Board of Education who kept calling me up. I've heard, we're winning, and eventually, the final recommendation was a quote compromise that it was just totally watered down to nothing. And there was an incredible amount of politics involved. One of the opponents to my side was a Latino activist who threatened to go on a hunger strike and I still remember that was also the superintendent of the LAUSD. This is, I was told by the reporter from the LA Times who I dealt with, who was covering this, who I developed a good relationship with. He said, he told me, he said, oh, let him, he was Latino, so he could say, let him starve. He said, I could never use that line, but it really amused me. It was politics in a sort of, again, from those days, it was nasty. Given the way politics is now, I wouldn't have been shocked, and it's mild compared to, but it was really, I got involved in this nasty politics, and it was not a pleasant experience, but I learned a lot. And my side thought I'd put up the good fight. I felt we hadn't gotten much done. And, I decided this was not a way I wanted to spend my time. And so I never worked on it again.
Barry, at the same time that this is happening, one backdrop, at least chronologically, is the widespread adoption of personal computers, that computers were in the homes, they were in the classroom, and they were increasingly becoming part of an educational tool in math. Were you following these developments? Was that important at all?
Of course I was. You can remember I was yes and no. This was at the time when I was the PC Magazine columnist for computer math.
Yeah.
So I knew about the more sophisticated tools. I didn't know much about the tools that were available to high school, and I'm not sure there was much. This was 2000. I don't. We didn't really discuss it in the committee. There may have been some computer workbook, but it was not like it was 10 years later.
The math that you were thinking about was not the math of computers. It was pen and pad.
Oh yeah, it was definitely pen and pad, and it was not. The material in principle was the same material that was done in the traditional curriculum, except, or at least a subset of what was done in the traditional curriculum. It wasn't, there was some argument certain topics shouldn't be there. You know, one of the things that's always been a huge flashpoint in the math wars is the importance of the quadratic, the formula that solves quadratic equations. And tracking came up peripherally. I still remember at the first meeting, it was actually very interesting. So Wu, C.S. Wu, who I mentioned from Berkeley, was also on this committee, except when he attended, which was not that often, he attended by Squawk Box. So this was, there was no Zoom, there was not, but he phoned in on a telephone in his voice. And I didn't, of course, know that tracking was by this point considered a sin. Even though, I met some high school teachers who were quite sensible, although tended to lean in the other direction, but they sort of admitted on the side, yeah, tracking was really necessary. It made no sense not to tracking. They had a really good student, since they couldn't track him, they skipped him. But the first meeting, I started saying something about tracking and it said some things that in the context were just terrible. And before I finished, the voice comes out of the Squawk Box. What Professor Simon means to say is, and he cleaned up my language perfectly. But, it was, as I said, it was an interesting experience, but I understand why educational bureaucracies get nothing done. It's incredible. And it got nasty at some point. By the time it was done, I was officially, I had input, but I was not officially allowed to vote on the final committee report because one of the opponents had discovered that one of the computer books I'd written was published by McGraw-Hill. And McGraw-Hill, of course, has textbooks. And so it was claimed I had this terrible conflict of interest. It was really quite an experience.
Barry, the articles that you wrote for PC Mag, did they demonstrate to you that you needed a longer format to have your ideas? Is that where the idea of having computer books, monographs essentially came from?
No. Totally different. No. The computer books were, the PC Magazine articles were on specific things, and they were certainly long enough. And I learned, they were supposed to be so long, and I became an expert in writing up a software review in 500 words. That was not the issue. No, I was through some CompuServe forum. I hooked up with a guy named Woody Leonard. And he already was writing some computer books, and we had this idea that we should write, this new version of Windows was finally becoming a serious program. Windows 90, the first version of Windows that used more than the original 640 kilobytes. I mean, you talk about, we have gigabytes, 64 kilobytes, but in those days, it was not 640 megabytes, it was 640 kilobytes. So there was using more than 1 megabyte of memory, and it turned out I don't remember, there were technical issues involved with the structure of the processes that we used. And, I heard later this incredible story about how, anyhow, and there was also this discussion about shifting over to OS2, and there was this incredible mix, but it was clear the first version of Windows that used more than 1 megabyte, Windows 95, was coming out. And so he suggested we write a book about Windows 95, sort of uses manual, as it were, but for sophisticated people.
What was your insight that would not have been possible from a regular computer programmer?
I'm not sure that I just felt we couldn't do a good job of writing it. And our shtick that made it different, we had 2 shticks actually. The first shtick was we decided we'd write with a certain amount of humor. Now, I don't know whether it was good humor or bad humor. But I think I mentioned last time we had it didn't die. We had CTO. The book was called The Mother of All Windows Books, the original version, which was a takeoff. This was at the point Saddam Hussein had talked about the mother of all battles. So we called the book The Mother of All Windows Books. And we had these icons that had discussions with each other in the margins about what was going on. I had they were essentially alter egos for the 2 authors. One of mine was CTO Mao, and the other was Erwin, who was Schrodinger's cockroach. I don't know if I mentioned last time where that came from.
No, I don't think so.
So Woody had heard a story that somebody at IBM had written some kind of technical manual for IBM, which had mentioned the Schrodinger's cat paradox. And some PR person at IBM was aghast that IBM would put something out involving a dead cat. And so they insisted the cat had to be changed to a cockroach. So IBM had a book that discussed Schrodinger's cockroach. We felt this was so fine, we invented a character called Schrodinger's cockroach, who made various other, he and CTO, and so the book had some amount of humor, and it sold actually rather well, and I still met people who really felt it was the best Windows book they saw, because we the books that sold best in that era were things like Windows for Dummies. And there were imitators, and we rewrote a book that was intended to be Windows for not dummies. It was a very interesting time. I mean, by 2005, I did stop writing for the computer. The PC revolution was done, but at the time of the revolution, it was a remarkable time. The developments and the excitement, and it really was an exciting time. And it was an interesting hobby to be involved with, even though probably meant I wrote fewer papers.
Who was the audience?
Whoever bought the book.
But it had wide appeal? All kinds of people bought the book?
It sold, again, it probably sold 60,000 copies, which right? Math book sells 2,000 copies. And again, I met lots of people who, it was someone who wanted to understand